Okay, today we're going to continue adding and subtracting fractions. And we're going to add mixed numbers and do a lot more with our mixed numbers today. So our goal is to learn to add and subtract mixed numbers. And our first one, we're going to write the answer in simplest form. So we have 5 1/8 plus 3 5/6. Now, you have options. You do not have to change them to improper, and I'm going to show you both ways, but some kids really like to do that. So in this case, we're really just needing to get the common denominator between 8 and 6. And if we can find the least common multiple of 8 and 6, we know that it's 24. So we'll want to write both fractions with a denominator of 24. What does that look like? Well, we know that 8 times 3 is 24, so we take 1 times 3. 6 times 4, so we take 5 times 4. Remember, we'd called that factor like a fancy form of 1 because it's keeping the identity of the original fraction or mixed number. So now that we have a common denominator, we can group together and add the number part. They call that the integer part. So we have the 5 and the 3, which would make 8. And then the fraction part, the 3 and the 20, make 23. And remember that a mixed number is simply just combining the 8 and the 23 24ths. So that our final answer is 8 and 23 24ths. How about you try this one? We want to get a common denominator between 4 and 8. We know, luckily, that the common denominator would be 8. So we rewrite the fractions. We've multiplied 1/4 by 2 over 2, and that's the only thing we needed to change. Now group together the numbers, the integers, and group together the numerators, and you can combine them and write your answer, 8 5/8. Okay. Yesterday we learned about subtracting and how sometimes we might need to regroup. So if we are regrouping, what does that mean? Well, 7 1/8, that's equal to 6 plus 1 to make the 7 plus the 1/8. So we've borrowed basically from the 7 so that we can make the fractional part bigger or get an improper fraction in that fractional part. So we write that fancy form of 1 for the number 1 and add it to the 1/8 so that now we rewrite the number or change it to 6 9/8. So subtracting, and we might have to borrow in this example. So we first find a common denominator between 9 and 3, and we know that's going to be 9. So we rewrite the second fraction by multiplying 2/3 by 3 over 3. So we get 6 9ths. In this case, we're going to go ahead and subtract, and there's no regrouping necessary, okay? So 12 minus 8 will be 4. 8 minus 6 will be 2, and then we just put it together over the common denominator. 4 2/9. Let's see if this one has regrouping. They do have a common denominator already. So in this case, we're going to rewrite or rename the 17 1/8. We're going to borrow one whole number from 17 to make it 16, and the fancy form of 1 that we're going to borrow is 8 over 8. So look what happens if we regroup 17 1/8 to be equal to 16 plus 1 plus 1/8. Combine the fractional parts to be 9/8. Then you can subtract the 3 from the 9, and you can subtract the 12 from the 16. And our simplified answer would be 4 3/4. After you get 4 6/8, you can see that they have a common factor of 2, and you can divide top and bottom by 2. Why don't you try this? And remember that sometimes you're going to have to first get a common denominator before having to regroup. So sometimes these problems do get pretty involved and have lots of steps. So let's regroup the first one. We're going to regroup it and rename it to be 13 plus 4 over 4 plus 1 over 4. Combine the fractional parts to be 13 5/4. Now we can subtract the integers 13 minus 10 and subtract the numerators 5 minus 3 to get 3 2/4, and then add and simplify by dividing a common factor of 2 to get 3 1/2. Let's give this a try. In this case, you're going to be, you have a negative 2 5/6 minus a negative 1 1/4. The first thing I want to do is take care of adding the negative, or the opposite of the next number, which means I'm really going to be adding the number. So I'm going to show this in two different ways. One, let's rewrite the problem with a common denominator, and I know that 6 and 4 both go into 12. So I have 6 times 2, so I'll take 5 times 2. So I rewrite negative 2 and 10 twelfths. Remember that subtracting a negative is the same thing as adding a positive. And then I'm going to multiply this denominator by 3, so I'll multiply the numerator by 3. So I get 1 3/12. Now, because I have unlike signs, I have to find the difference of the two numbers. Now, I knew something didn't look quite right. Let's get that right. Okay, so now we have it in the right form, and we will find the difference. So what we can do is we can subtract. We can take our negative 2 and 10/12. We will be, I'm going to not even put this negative here. I'm going to keep the negative in just the original problem so it doesn't confuse me later. I am taking away the 1 3/12 because when we do this, we can keep it in the mixed number form and just always find the difference like we did in our integer problems, where you take the smaller value from the larger value no matter where it is in the problem. So 10 minus 3 is 7 over 12. The integer part, 2 minus 1, because we're finding the difference, is 1, and then I go back to my original problem and I evaluate which one had the higher absolute value and what was its sign. Since the higher absolute value is 2 10/12, it's negative, my answer is negative. Okay, another option that we have is to go back to our original problem. So this would be called like method 2. I'll draw a little dotted line because you do not have to do both. Is we could change them both to improper fractions. Now note that when you do that, sometimes you're going to be dealing with larger numbers. So 6 times 2 is 12, plus 5 is 17 over 6, and this is my negative. And then minus, and then I have 4 times 1 plus 1 is a negative 5/4. Okay, again, dealing with these, adding the opposite. I have to get the common denominator, so here's where I will multiply by 2, multiply by 2, multiply by 3, multiply by 3, and rewrite it to a negative 34 over 12. Dealt with my double negative, and I'm rewriting it as an addition problem now, as 15 over 12. When I combine negative 34 plus 15, I'm still finding the difference. I'm subtracting 15 from the 34. I'm going to get a negative 19 over 12. And when I change that to a mixed number, 19 divided by 12 goes in one time with 7 as a remainder. So note we get the same answer either way that we do it.